lecture, we have already seen what peer review is and what the different types of journals are. And we also saw what the different types of articles are. So right now we'll talk about what basically is the journal indexing and why it is so important for our for any researcher, why it is so useful to understand it very clearly. So basically, the journal indexing is a bibliographic index which is intended to help find some publications. So think of the journal indexing or the bibliographical index as a database where all the similar kind of papers or all the similar kind of journals are stored. Okay. Here, this similarity is based on quality rather than uh, similarity in terms of subject. So if I have to give you a more example, for example, you walk into a furniture store and you see the different and the furniture owner. If you walk into a big furniture store and the furniture owner gives you a catalog of all the different kinds of designs he has. So that catalog contains all the specific designs that he may have, though they may be on the display or they may not be on the display. But it gives a list of all the different kinds of furniture that the store possesses or the particular shop has. Similarly, a bibliographical index is a database or a catalog of all the journals that are indexed in that particular database. Okay, so it helps the researchers or it helps the readers to find different kinds of journals and papers and publications among this database. Now, uh, this database is primarily made in two different ways. The first way is that the first focus is on the type of papers in the sense that the quality of the papers. So there, each database has some kind of quality standard based on which it indexes different kinds of journals. So a journal, first the indexing of a journal happens. For example, if suppose say there is a journal called International Journal of XYZ. So that International Journal of XYZ would apply for indexing to that particular indexing agency, and that indexing agency will look at the different kind of criteria while listing the journal of XYZ in their database. If it fulfills the criteria, then it will be indexed in that database, and if it doesn't fulfill, then it will not be indexed in that particular database. So that is the first kind of uh, classification or first kind of criteria that is there to index a particular journal in a database. The second criteria that is there is that, for example, there are very specific lists. For example, there are very specific lists like the SCI or the SCIE or the AHCI, where once the quality issue is also there, once the quality criteria is also there, the other criteria is that they should be from a particular domain. For example, for a journal to be listed in the SCI, the quality requirement is very high, as well as the subject requirement is that the journal should be broadly from the field of science, technology, engineering, and management. Similarly, there are certain other papers or certain other journals, in fact, which may be from arts and humanities. They are not listed in the SCI, not because they do not meet the quality criteria, but because they do not meet the subject requirement criteria or the subject shortlisting criteria. So they are grouped in an equivalent ranking called the AHCI, that is the Arts and Humanities Citation Index. Similarly, there may be some particular journals from social sciences which may not be covered in SCI and AHCI because they do not meet the subject requirements because they are from social sciences. So they will be grouped in the SSCI, that is the Social Sciences Citation Index. Okay. So basically, if we look at the different kinds of journal indexing, the basic idea of all the journal indexing is to help the readers understand that this is a particular database, and in this database, a particular set of journals is listed, and this set of journals are like-minded in the sense that they belong to a particular domain as well as they have a particular quality standard. So the requirement of the quality standard or setting of the quality standard depends on the indexing service or the indexing agency. Now let us look at what are the different kinds of indexing services that are out there, or the reputed indexes, journal indexes that are out there. So the most reputed indexes by far is the SCI list. Since 2019, the SCI has ceased publication of the SCI list, and now it is publishing something called the SCI list. So before 2019, the agency which used to publish the SCI, it would publish two different lists called the SCI and SCIE. So SCI is Science Citation Index and SCIE is Science Citation Index expanded. But from 2019, they have merged both the list, and the SCI list doesn't exist, and only the SCIE list exists so far. So this is the most premier kind of indexing that is out there. So for any kind of quality metric, you should always understand that SCI, SCIE, SSCI, and AHCI are considered of equivalent ranking, where SCIE is from science and engineering background as such, in general, and SSCI is from social sciences background, AHCI is from arts and humanities background, and all these three are considered to be of equivalent level in the different fields of study that I have mentioned. One from the science and engineering, the other from the social sciences, and the third one from the arts and humanities. So this is the most reputed kind of indexing that is out there. So generally, what a researcher should do is that the if his paper or if his research meets the quality standard of this kind of indexings, they should go for journals which are indexed in this particular indexings. Now, we'll learn more about the SCI and all this in detail in the next slide. But before that, let me tell you that the widely accepted norm of the second category is the Scopus category. So Scopus is also a very large database which started in somewhere around in 2012, and since then it has been continuing. Now there are some other additional indexes by the same agency which gives the SCI SCI list called the ESCI, and there are different kinds of other lists also. So these are also some reputed lists, but however these are considered to be a little inferior than the SCI and the Scopus. We also have something called the Google Scholar, which all of you might be aware of. We'll also learn about the Google Scholar in detail in the later slide. So let us first look at the SCI, SCI, SSCI, and AHCI. So the SCI was initially started as a citation index by a researcher called the Eugene Garfield, and he set up a particular institute that was called the Institute of Scientific Information. He set this up in 1964. This business was, or this particular institute was later bought by some other agencies. For example, the Thomson Reuters managed this SCI list for a long time, and recently, in the last 2 years, it has been sold to Clarivate Analytics. Now, Clarivate Analytics is the sole owner of SCI list, and it is tasked with the list of maintaining the list as well as updating it year-wise. So, what you have to understand is that this SCI, SCIE, SSCI, AHCI list are maintained and updated each year. So a number of new journals are added to the list significantly. Similarly, some additional journals may be removed from the particular list. So all this adding and deleting of the journals from this list is based on the internal quality requirement of the SCI organization or the Clarivate Analytics. There is a particular rubrics based on which they decide whether these particular journals meet the criteria to be indexed in the SCI list or not. Okay, here another clarification I want to make. Throughout the workshop, when I will be using the word SCI, I basically mean all SCIE, SSCI, AHCI, and so on. So I mean all these four indexes when from now on I'm saying the word SCI. So this SCI database is hosted by the Clarivate Analytics, as I told you, and this can be searched by different kinds of search platforms. For example, the Web of Search platform. You may have heard of this name. So Web of Search is the kind of the uh, Google search for this particular database. Okay, you can think of it as a search engine which searches the database, this particular databases for the different journals that is there. There was also a similar search option called the SCI search, and this is the particular website of the SCI list. So we'll just go over there and take a look at the website. So this is the website of the SCI or the Thomson Reuters. Here, sorry, now it is Clever Analytics, not Thomson Reuters. So this is the particular website of the Web of Science, where you can find different kinds of journals that are indexed here. So at present, if I am not wrong, around 15,000, roughly somewhere around 15,000 journals are indexed in the this list, in the SCI list. So what you can do is that if you want to search an particular paper and a particular journal, okay, here again one more thing I should tell you is that the individual papers are not indexed in a indexing. The journals are indexed, means the overall quality and overall standard of the journal is assessed, and based on that a decision is made whether these particular journals should be included in the database or not. So once a journal is included in the database, automatically all the papers that are published in that journal during the time of the coverage are directly included in the database. So the what you have to understand is that individual paper to paper quality check is not done, but on a broader scale for the entire journal the quality check is done, and once the quality check is approved, it is true for any kind of indexing agency, not just for SCI. It is true for any kind of indexing service. So overall the journal is assessed, and if it is found to be within the limits or within the criteria, fulfilling the criteria of that particular indexing, then the journal is indexed, and automatically the papers which are published in their journal during this particular period of time when it is covered in the indexing are automatically reflected in the database of that particular indexing. So now let us look at this website. So this is the homepage of this website. So here what you find is that you find something called the master list. So if you click here, so you should get a list of all the journals that is there. And if this is not available, you can go and search here. So in the search option, for example, you know the name of the journal, then you can type here the name of the journal which you are trying to see. If you know the ISSN, you can type here. And sometimes, suppose say if you do not know if you are not sure about the name of the journal, maybe you can write the word. For example, I will write structural. So it will show me all the journals that have the word structure in its name here. So as soon as I search the word structure, so what you should understand is that this particular search, or this is the web of search, this particular web search is for all the indexings that the Clarivate Analytics holds, not just for the SCI list. So here, as soon as I search the structure, so you find that I have around 144 results which are shared here. And for example, here you find something like this, that advanced structural and chemical imaging. This is a particular journal, and it tells you all the information: who is the publisher, what is the ISSN, which category it is, and which core collection is it in. So here it tells you that it is in the emerging sources citation index. It means it is in the ESCI list, not in the SCI list. So you have to be a little careful when you are searching this website. Just because some journal is mentioned here, it doesn't mean that it is in the SCI database. You have to look at this in which web collection it is, because the same Clarivate Analytics, they host a different number of other indexings also, like the ESCI, like the chemical abstracts and all that. So you have to look at in which particular category it is listed. Okay. So if you want to know a little more about this, what you can do is that you can just click here, view profile page. So for this you may need a login. So the login is very simple. For a basic kind of login, what you can do is that you may log in from Facebook, Google, LinkedIn, or Orkin. So I'll log in with my Google. I've already registered here, so no need to register again for me. So registered here. So it will take me to this website now, and once you log in, your account name and everything will be shown here. And here it shows the details, additional details of the journal when you click on the journal profile page. And here it gives you the actual website of the particular journal, and all the, other details of the journal are listed here. And for example, there are some additional information like in which Web of Science collection it is and what type of journal it is. Is it a open access journal? Is it a signatory of directory of open access journals, and so on. So all this kind of information you can get from here. So let us go back and let me show you a journal here which is listed in the SCI and how it would look like. For example, this particular journal, Chinese Journal of Structural Chemistry, this is listed in the SCIE. So what additional information you will get here when you log in here? Let me click here. So additionally, you will get all this information regarding the country of origin and all that, how many issues published in a year, all this kind of information you will get. But additional information you can get from here is something called the impact factor. What is impact factor? We'll see in a bit, but you get to see the latest impact factor. What is the latest impact factor of that particular journal from this particular website? So here, for example, for this particular journal, it says that the impact factor is 0.69. It is the last impact factor, that is it is the latest impact factor is displayed here, and the appropriate report in which this impact factor was published is also mentioned here. For example, this is the 2018 journal impact factor and it was published in Journal Citation Reports 2019. So if you have a more subscription based access, you can get other relevant details here. But since I do not have the access to this, I have a very basic subscription here, a basic free subscription model here. So I am able to see only this information. If you have an additional subscription, a paid subscription, maybe you can look at all the other features about the 5-year trends and all that. I will show you some other websites where you can get this information for free. So you need not have a paid subscription here in that case. So coming back to our slides, so we'll move on to the next slide, that is on the Scopus. So Scopus is another database which was launched in around 2004, and it was launched by the acclaimed publisher Elsevier. Elsevier is a publisher which is very active in the STEM field, in the science, technology, engineering, and management field, and they come up with a abstracting and citation database that is called the Scopus in 2004. And right now it contains around 36,000, roughly around 36,000 articles or titles, sorry, not articles, total titles and periodicals and journals in this database. So if you analyze this data, you will find that this is about 3 times the size of the SCI, which also means that the quality requirements in the Scopus are a little low as compared to the SCI. So this is the website of the Scopus. So let us click here and go to that particular website. So the website is www.scopus.com. So the website is similar to that of the Web of Science website. So here also, as soon as you log in, as soon as you go to this website, you get to see this kind of a home page, and here you will get a lot of list. For example, here if you want to download the latest Scopus list, you can download it from here. Here if you want to see the Scopus or the journals which are previously indexed in Scopus but are discontinued, that you can see here. There are certain books which are also listed in this Scopus. That book list you can see from here. Okay, all of this you can download by having a single click here. I already have this list, so I'm not downloading them, but if you want, you can download them. And what additional information you can get here, similar to the Web of Science database, here also you can log in by using your Gmail ID. I have already logged in. Okay? You can make a free account here and you can log in by using a Gmail ID. Now, if you want to search the different kinds of sources means the different kinds of journals and the books and the volumes that are there. So you can click here, you can go to the sources, and similarly, here based on whatever the keyword, whether the keyword you are searching or whether based on the subject area you are searching or based on the publisher and the ISSN you are searching, you can use any of this field. For example, I am going with the subject area and I am going to enter the subject area as, suppose say I am interested in mechanical engineering. So I'll go for the mechanical engineering, or suppose say I'm interested in the materials. I'm interested in the materials. I go and click here. So it will list all the different kinds of journals which are listed under the material science category. So it will show me all the journals that are listed in the material science category, both active as well as inactive. So you have to be a little careful while seeing this here, while seeing this list here, because it lists both active as well as inactive journals in the list here. For example, let me show you. So here it also gives a lot of other information like site score and all this. We'll look into detail what this means and how you can use them to select a proper journal. For example, let me reverse this. Let me look at the lowest journal. For example, this is the ACS applied biomaterials. So I can click on this, and as soon as I click on this, so here's some information you will get, like this is the ACS applied biomaterials. ACS is American Chemical Society. It is again a reputed society. So this is a relatively new journal which is covered since 2018. So here, when you look at the Scopus database, what you should look at is from which year it is covered. So here it is showing that it is covered from 2018 to present. So another thing what you have to look here is that whether there is any break in the coverage. What I mean by here is that whether suppose say in 2018 it was indexed, but in 2019 it was not indexed, again in 2020 it is indexed. This kind of breakage in the indexing you have to see. If there is any breakage in the indexing, it generally means that there was some kind of quality issue during those particular periods, and that journal is not a very stable journal as far as the ranking, as far as its indexing in the Scopus or any database is concerned. Okay, any reputed database is concerned. So you should always go for journals in the Scopus database which have a very stable kind of rating here, or which have a very stable kind of entry in the Scopus database here. So you get to see other informations, like you get to see the Scopus coverage years, you get to see which particular publisher publishes, ESS and all this thing. You get additional details like the site score tracker and all that. We'll look into this in a little while, but this is the basic kind of information that you get. And once you click on this page here, Scopus coverage, content coverage, you get something called this content coverage. Since I do not have the full version, I cannot see the individual papers, but if you have the full version available with you, if you have the full access to the Scopus database, then you can look at the individual documents also which are listed here. So here it tells me that in 2018, 224 documents were indexed in the Scopus database, in 2019, 613, and in 2020, around 245 documents have so far, or articles have so far been indexed in the database. So let's go back. So, for example, let us look at a bigger journal. So here, suppose say this is an old journal, very old journal by Taylor and Francis called the Advances in Physics. So you see that this particular journal is covered in the Scopus from 1952 to 2009. So immediately a doubt comes into your mind that I already told that Scopus was started in 2004. Then how come this particular journal is here from the 1952? It simply means that for some reputed journals which were there even before the Scopus existed, what Scopus did was that they uh, they had some agreements with their publisher, and the back issues of that particular journals are also listed here. That is why in some journals you will find that they are listed from certain years like 1952 to 2019. Okay, so it means they have been listed here uh, since the uh, since some earlier date, even before the Scopus existed. So again, the similar kind of information you will see here. Since this is a old journal which has already covered more than 3 years, so you get to see additional information like site score and all this here. This information was not available in the previous example because it was a relatively new journal with only 3 years of volume. This is a old journal with a lot of volume, so you get all this kind of information. Any journal which has completed more than 3 years will have this kind of information available here. And what are this information we'll see in a while. So here you find additional information like the calculation of the site score rank and trend. So it shows you that within a particular field, for example, in the field of condensed material physics, what is its rank? Its rank is 1 within that particular field. And it tells you the site score, and it tells you the journal coverage. For example, from 1952 till now, all the journals that are indexed here are shown here. Now, let us go back to our discussion. So there is another database that I didn't mention in the initial discussion on the databases. That is the Medline database. So Medline is the acronym for Medical Literature Analysis and Retrieval System Online, or the Medlars Online. So Medline is a website or is a database that is specifically for the domains of medicine, nursing, pharmacy, dentistry, veterinary medicine, and health care. So it is a specific kind of abstracting service or database uh, which is for the uh, medical community as such. It doesn't specifically list the engineering papers in it, though it may contain some journals which are from the bioengineering part or from the biomechanics part. So Medline is maintained by the US National Library of Medicine, and it was started in around 1946. And so far, it contains around 26 million articles from around 5,639 journals and publications that are listed here. You may have heard the word PubMed. So PubMed is basically a free search engine which is used to search the database of Medline. For example, you know now about the Web of Science. So Web of Science is kind of a search engine to navigate through the entire uh, entire database of the Clarivate Analytics or the Web of Science database, which contains the SCI, SCI, SSCI, ESCI, and all these things. So similarly, PubMed is a free search engine which can be used to navigate through the Medline database. Okay. Similarly, the Scopus has its own search engine, the Scopus search engine, to search through all the Scopus papers. So next we'll look at something called the Google Scholar. So Google Scholar is very famous among all the researchers, and it was started in 2004. And Google Scholar is basically what I want to tell about Google Scholar is that it is both a database, as at the same time it is not a database. Okay, it is an indexing as well as it is not an indexing. It is not an indexing, but it is a database and it is not a database. What I mean by this statement is that the Google Scholar or the algorithm of the Google Scholar or the search of the Google Scholar is similar to its counterpart called the Google search engine. So what happens in Google Scholar is that Google Scholar is a very powerful search engine that is specifically for scholarly articles, or that is specifically for research articles, and as well as patents. And this particular Google Scholar search engine searches through the entire internet, and it indexes all the papers that it can find in the internet. Okay? So it is a indexing in this, it is a database in the sense that it maintains the different kind of papers that are there in the internet in its own servers. Okay, that is why it is a database. But why it is not an index? It is not an index because it is not a full-fledged index, because it doesn't have any quality requirements. Okay? What I mean by this statement is that if you look at organizations or indexings like the SCI or the SSCI or the ESCI or the AHCI or the Scopus or the ESCI and so on, in all these indexings you find that they have a set of written rules that these are the quality standards. These are the quality standards that a particular journal has to meet before getting recognized by us. Okay, that is what they mention. Whereas in case of Google Scholar, there is no quality requirement. There is no requirement that a particular journal should be 1 year old or 2 year old, or it should have come from a particular domain, or it should contain proper peer review and all that. So any kind of quality requirement is not there to index in the Google Scholar. That is why Google Scholar is not a full-fledged indexing. Rather, it is like a enormous and very powerful search engine which lists all the papers that are there in the internet and maintains in its own database. So Google doesn't release any information about the database that they have, the volume of the database that they have. But some researchers in 2018 conducted a survey, and they estimate that around 389 million documents, including articles, citation, and patents, are there in the Google Scholar database, which makes it the world's largest database. So any paper that you have written, it may be a published paper, it may be unpublished paper, it may be it may be open access journal, it may be a subscription based journal, it may be any kind of research article that has been published will be indexed in the Google Scholar, or it will be available through the Google Scholar. So basically, Google Scholar is a, you have to remember is that Google Scholar, rather than being a indexing, it is a powerful search engine which maintains its own database uh, of the different kinds of journals that is out there. So please be aware whenever a particular journal mentions that it is indexed in the Google Scholar. So please be aware that it is not entirely true, because there is no quality requirement to get indexed in the scope in the Google Scholar database. In fact, there is no form also to be filled by the publisher to get indexed in the Google Scholar. Google Scholar automatically, based on its algorithm, it automatically detects the papers that are available in the internet, and they are displayed through its website. So let us look at the website of the Google Scholar. Directly go here. Let us try. So the website is scholar.google.in. So here also, what you can do is you can have a login for yourself. For example, let me log this out. Here you can log in. So this is the basic Google Scholar page that you will see, and you can log in using your own ID. For example, you can log in using any ID that you have. So this is what it will show like this. So after you have searched a number of papers here, it will even show you the recommended kind of articles. Based on your search history, it will show you recommended kind of articles. So here, what happens is that in the Google Scholar, if you click here, you can find my profile, which basically shows the profile of the researcher who is logged in, and it shows something called the My Library. In the My Library, it shows you all the different kinds of articles that you have searched, or the different kind of journals that you have searched. And this is the important part called the metrics. So here, if you click, here it presents you with a database of all the top indexings, or all the top, sorry, not the indexings, the top journals that are indexed in this particular database. For example, right now it is showing me the top publications. So these are the top publications in the world. So it shows a list of around 100 journals, which are the topmost journals in the world. For example, you see the journal called the Nature, which is ranked the most highest, followed by the New England Medicine Journal of Medicine and the Science. So these are these particular four journals. In fact, this particular five journals, you will find them to be listed in the top in any kind of indexing services. So you'll find that the ranking may be a little different for them. Sometimes Science may be ranked one, sometimes Nature may be ranked two, sometimes New England Journal may be ranked one. But over the last 10 years from which I have been following them, I have seen that these generally maintain the top five spots in the publishing category, or in the top five publication category. But all of them are specifically from they focus more on the medicine background. So here, additional information what you can get is that if you click on the categories, you find a lot of other information here based on the different kinds of categories. For example, business economics, you get engineering and computer, you get humanities, everything you get here. So let me go to the engineering and computer. So if you go to the engineering and computer science, within that you will find a number of different kinds of subcategories. So based on these subcategories also, there are some ranking list that is there. For example, let me go to the structural engineering. If I go to the structural engineering, within the structural engineering also, a list of 20 articles are shown here. A list of 20 journals are shown here. So in all these subcategories, you will find that they maintain the list of 20 topmost journals in this particular categories. Now let us look at something called the citation index and why it is important. So basically, before understanding what a citation index is, let us try to understand what basically a citation is. So whenever you are referring to a particular paper in your reference or in your paper, you are basically giving a shout out to the fact that you have used the you have used some kind of information from that researcher's paper, and you want to acknowledge the contribution that the researcher indirectly has made to your paper, right? So that is the basic idea of citation. So citation, the reference section of your particular paper makes the citation for any kind of journal. Okay. For example, if you have written a paper and if you have included, if you have written a paper and for example, when you write a paper and you cite some papers where you refer to some other researches in them or articles in them, then basically you are citing them. Okay. So if suppose say in one paper, in your paper, suppose say you are referring to a particular article. Suppose say the name of the article be XYZ. So if you are referring to the article XYZ in your own paper, suppose say within the text one time, and in the reference section you put its description, suppose say xyz, where it was published and which journal it was published, in which volume and which year. So it means basically you have given one citation to that particular paper. Okay. So citations are generally given to individual papers which are then collected or which are then sum total for the entire journal. Okay. So citations are given to individual journals by the researchers, in individual papers by the researchers, and this entire citation is collected and calculated and summed up to find out the total citation of a particular journal. Okay. So what happens is that, and all this collection of the information is done by different kinds of indexings based on where it is listed. For example, if you look at the Google Scholar, it lists all the citations that a particular paper has, and then for all the papers that are published in a particular journal, it calculates them and it tells you the citation index metric. Similarly, in the Web of Science, what happens is that the Web of Science calculates the citations that the journals indexed in the Web of Science receives, but from journals which are also indexed in the Web of Science. Okay, I hope you understood the difference. So what basically I mean by here is that, suppose say there is a journal A and there is a journal, and there are some other journals B and C in a particular area. Okay, so there are three different journals A, B, and C in a particular area. Suppose say if you want to calculate, and let us assume that there are only three journals and there are no more journals in the Web of Science. Okay, only these three journals are there. So what happens is that, so when you calculate the total indexing of journal A, you look at all the citations that the journal A has received from journal A itself, as well as from journal B, as well as from journal C. So you sum this total up and then you calculate the total number of citations from journal A that is listed in the Web of Science. Suppose say there exists another journal, journal D, which also refers to the papers of journal A, but it is not indexed in the Web of Science. Then the citations given by the journal D are not calculated. Only the journals, only the only the citations that are available from the journals that are within the Web of Science are calculated for calculating the citation index of the Web of Science. The concept is similar for Scopus also. In the Scopus also, if suppose say there are three different journals and all of them are in the Scopus database, so only the citations by those journals as well as the self citation is included while calculating the citation index of that particular journal in the Scopus database. Any journal which is not there in the Scopus database, the citation by that particular journal is not calculated while calculating the citation database. So this is also something that you have to keep in mind. So that is why what you will find that there is always some kind of discrepancy between the number of citations in the Google Scholar, number of citations in the Scopus, and number of citations in the Web of Science. So generally, as the index goes on becoming more and more selective, the citation also drops. Okay. What I mean by this is, if you look at the Scopus, sorry, if you look at the Google Scholar, you will find that it lists each and every one of the journals that is out there. Let me show you this by my own example. So here, instead of the indexing of a particular, instead of the number of citations by particular citations for a number of citations for a particular journal, I will show you on an individual level, because the concept is same for individual researchers uh, as well as the journals. So let me go to my profile. So here, if you can see on the screen, in the Google Scholar page, this is the website or this is the web page, or this is the profile that I have in the Google Scholar, and it shows that I have around 411 citations in the Google Scholar page. But let us go to the Scopus and let us see how it differs in the Scopus database. So in the Scopus database, you can go to the author search, or in fact, since I am already logged in, I can go to my dashboard. So to account, okay, 1 minute. Okay, I'm logged in with the wrong account. That is why it is not showing. So what I can do is, I have this somewhere here. I have this here somewhere. Rather than logging again, I already have this information here. So what you can see here is that if you saw my Google Scholar page, the total number of citations that I have is around 411. And similarly, but in the Scopus database, if you see, the total number of citations that I have is around 223. Okay. Similarly, here, if you see the total number of articles that I have in the Google Scholar, that is listed as 60, whereas in the Scopus that is listed so far as 42, whereas the actual count is around 47. There is generally some delay. There is some delay in the indexing here. What happens is that after a particular, as soon as a particular journal or as soon as a particular article is published, as soon as it is published, within 24 hours, that is available in the Scopus in the Google Scholar database. Whereas in the Scopus database, it takes at least, suppose say, 1 month for some journals. In some cases, it may take 2 to 3 months depending on whether the volume number has been issued or not. Similarly, you can go to the Web of Science database, and if you have a website there, in the Web of Science database, there also you can see the total number of citations that you have in the Web of Science database. So what I mean to say here is that as the database becomes more and more selective in terms of the number of journals that is indexed there, the citation will also go on decreasing. Okay, generally we'll find the highest number of citations for any individual or any journal in the Google Scholar, followed by the Scopus, and then followed by the Web of Science.